internal in-service robotic inspection. I'm guessing it's the stepbrother to Siri. Joking. Take it away, Zaini and Isham.
Thank you. All right, Assalamualaikum and good morning, ladies and gentlemen. My name is Muhammad Zaini bin Muhammad Zakaria. I'm from MCI GTS, and today together with me is my colleague TP Nur Hisham Muhammad from TSD PPTSB. We are going to present a paper entitled A New Way of Inspection, Tank Internal In-Service Robotic Inspection, or better known as TIRI. All right, okay, let's start our presentation, my presentation with a background to give you a context setting on this technology. The conventional way of inspecting a storage tank by using UT crawler or UTTM, which are normally used to measure the shell thickness measurement. That's one test. The other one is theodolite, which is normally used for tank bottom settlement. So both tests can be done while the tank is in service or online. However, in order to determine the integrity of the tank bottom, we need to shut down the tank, empty the product, and also prepare for the safe entry for us to perform magnetic flux leakage on the tank bottom. Okay, alternatively, nowadays, I think we have this robotic inspection available to check the integrity of the tank bottom while the tank remains online or in service. Don't worry, I think this robotic inspection is permitted by API 653, which it can give a direct quantitative assessment together with combining with statistical analysis to determine the tank bottom condition, its remaining life, and also out of service interval. All right, so it is expected that this technology is able to address some of the common challenges or pain points faced by our operating unit in managing atmospheric storage tank, including operational constraint due to opportunity loss, high cost from tank cleaning and waste disposal, safety issue from personnel working in confined space for a long time, longer maintenance downtime, and as well as environmental risk from hydrocarbon spill or VOC emission. All right, this technology, I will say, it has been developed by a few companies and is commercially available in the market. And I will say that this technology is a mature technology and already successfully deployed worldwide. For the field test, I think we have these two types of robot, electrical and hydraulic robot. Technology verification have been done in Petronas at one of the Petronas plant last year. And most importantly, I think this technology has been successfully endorsed at TRL7 for Petronas OPU deployment. All right, let me introduce to you to the first robot. The first one is the electrical robot, which is normally used for utility tanks, white and light products. This is the first one is the electrical robot. I mean, it is equipped with a camera, blower, pout probe, phase array probe, sonar pinger, blower suction hose, and also umbilical cord, umbilical cable. Sorry. The weight of this robot is around 100 kilogram, and the length of this umbilical is around 100 meter. That is for the first robot. The second robot is a more robust robot. It is a hydraulic robot, which is used for volatile, heavy and black product, including product with expected slash. I think the robot is equipped with the same features as the electrical robot, but without the camera. The weight, I think, is slightly heavier, around 20 kilogram heavier, but the length of the umbilical is very long, which is around 300 meters. All right, this is the basic operation, how we handle this robot to do the inspection. Normally the equipment and system setting, including the calibration, was done on the ground. And then the safety interlock system was set up and tested before the deployment. And then the robot will be lifted up, to the top of the tank, and then sent through the mainway to the bottom of the tank using a tripod system. And then after that, only the robot will be energized and remotely controlled from the control container to propel and measure the thickness inside the tank bottom. All right. Okay, this is the field test conducted at basically PPTSB last year on 5 identified tanks, comprising of several tank design and also services, ranging from demin water, utility water, fire water, diesel, and also condensate. All right, okay. For this one, I think for the theory technical evaluation, I would like to call upon my colleague, TP Nur Hisham, to share his experience using this technology. Please, TP Nur Hisham.
Thank you, TP Zaini. Assalamualaikum and good morning, everybody. My name is Nur Hisham from Technical Service Department, Petronas Penapisan Terengganu. So allow me to continue with the presentation. Ladies and gentlemen, fellow TPs and online audience, Petronas have operated atmospheric storage tank for more than 40 years, or at least at 50 SB. However, in leveraging technology in day-to-day activity for operation, maintenance, inspection, may be a little bit lag behind or in some cases overdue. So this is our take or our step up in challenging the norm in supporting the MFT 50 aspiration. So to be first at Petronas, we are validating this technology not only for Penapisan Terengganu, but also for the whole Petronas tank fraternity. So there are 4 testing criteria to be validated. First, the safety and system applicability. The robot need to be safe and reliable to be operate in flammable and hazardous environment. And it also need to be able to be operated without causing any disruption to tank operation. So on the second, on the NDT capability, the NDT should able to accurate and able to measure the thickness data quantitatively to comply with the code requirement. So we are also evaluating the competency of the personnel involved in this technology, from the robotic operator to those who participate in the analysis. And last but not least, the navigation capability. Will be operate this robot in a pitch black condition inside a hydrocarbon tank. So having a navigation capability is crucial to detect any potential obstruction and to avoid the obstruction during the operation. So we would like to make it safe for us while try to accommodate our constraint. So as everything else, it comes with a risk. So theory is a multidiscipline effort. We have a team from electrical, instrument, operation, HSC, and mechanical to support and to develop the risk assessment as well as JHA development. So this guy also identified the appropriate mitigation to ensure that theory can be safely operated inside our hydrocarbon tanks. So example of the mitigation identified from this discussion is, if I may recall, is overcurrent protection, the requirement for functional testing, as well as the scan plan agreement prior to the actual deployment of the robotics. So we learn a lot from each other, and we also learn a lot from the service provider during the discussion. So compliance to the agreed JHA and procedure is crucial in assuring the robotic tank inspection. So alhamdulillah, we are able to successfully and safely deploy both theory electrical and hydraulic robots. Damage to the asset or unwanted incident. All of this was conducted during Tank Online. Theory could provide two inspection data. First is the bottom thickness, and second is the visual of photo or video from the tank internal. To ensure we have reliable or good thickness data, we did a couple of calibration and thickness validation using a two thickness plate as well a plate with defect of various sizing inside a temporary water container to simulate the actual tank robotic inspection activity. And the HD camera installed for the utility tank able to capture significant or related condition of the tank for further analysis. The tank design need to be analyzed. So the location of the manhole, the internal catalytic protection system, your roof drain piping, or other internal tank internal pertinent accessories will determine the possible inspection location, as well as supported by the corrosion and the historical inspection record from the previous inspection. In addition, there are also sludge or sediment inside the tank that will hinder the reliable data from be captured from the robots. With all these challenge, Thierry able to capture the more than 2% data for compliant to the codes for further analysis. So from owner side, we require multidiscipline team from operation, inspection, electrical instrument, and etc. From the contractor side, we verify that there are personnel qualified with NDT certification. They are also experienced robotic design and operator, as well as authorized tank inspector, and personnel involved in the statistical analysis have the required certification. As I mentioned before, there are obstructions inside the tank. So these accessories or pertinent could be detrimental to the robot during the inspection. It will increase the risk of entanglement and the robot may be stuck in the tank. So Thierry utilize 2D imaging sonar system which are able to detect or identify the obstruction, and its positional capability able to maneuver the robot from the obstruction when required. Inspection for 6 tanks are safely and successfully conducted. So we are also able to capture the minimum data to perform the analysis. So from the analysis, we are able to determine or estimate the minimum thickness for the tank bottom and subsequently the recommended internal inspection interval. So further validation revealed that there are only 6% variance between this estimated minimum thickness from theory and statistical analysis compared to the actual minimum thickness detected using conventional method 4 months after inspection. This was done during tank shutdown. So it is good condition as well as with the embedded safety factor in the calculation should give us confidence to make the decision. TRI deployment can provide significant value if deployed in Petronas. It is code compliance and within the governance. Its technology is safe and proven, as well as the technology avoid tank operational disruption. So the data or result analyzed could be used to extend the OS interval and translate to the minimizing maintenance costs, where we can normalize the maintenance costs throughout the tank operation life. And as minimum, it can provide the actual condition of bottom tank for optimized OS planning in the future. So based on field testing conducted at Petronas plant or at PPTSB, we are able to extend the tank interval or OS interval for 4 tanks out of 5 tanks inspected. So this translated to RM 8.7 million optimization based on the postponement of the maintenance costs. So this is our takes in supporting MFT50, and I'm sure you guys also have your own ways. So thank you for your attention.
Hi, Zaini, Hisham. Thank you
Yes.
very much for the presentation. It's very good. So you guys didn't bring Tiri in today, is it?
The what?
You didn't bring Tiri in today, is it? Di anak Tiri kan tak masuk dalam TV forum.
Unfortunately, no, tak ada ini.
No, we don't bring theory.
Okay, it'll be nicer if you have show and tell lah kan. But anyway, okay. Just a question. Tiri is operated through umbilical, right? Umbilical cable, right?
Umbilical cable, yeah.
So, is there any plans to develop a wireless one?
Oh, let me answer this one. Okay. This robotic inspection is evolving very fast in the market. Basically, currently, okay, right now, I think we have I think one of our initiative even for Petronas. I think we are exploring some of the company who can do a very a robot which can dive and swim around the tank and landed on the tank bottom. So that will be part of it. And then the other one is basically they are exploring the possibility of maneuvering inside the tank with a heavy sludge. So that is one of the things that is currently being researched by a company around the world. And I think one of them, I think we are also part of it. I mean, in the research and development of the robotic inspection.
Okay. Another question would be that it depends on the size of the Tiri robotic itself.
Yep.
As well as the size of the tank and the manhole where you insert the robots, right?
Mm-hmm.
So that's the current limitation. Am I right?
You want to answer the size? I think the size of the robot.
Beg your pardon, sir?
No, because different tanks will have different dimension, will have different internals, will have different manhole size where you can put the robot in, right? Obviously, if the manhole is smaller than the robot size, you can't use Tiri. Am I correct?
Yes, pretty much correct, sir. So basically, manhole size for tank are standard, either 24-inch or 30-inch, depending on the tank size.
Right.
But the manhole location will determine the possible inspected area.
Yeah. Well, we were discussing just now, me and Fat, because it all depends on where the manhole location is. Because, for example,
and the size of the manhole as well.
Yeah, because it's
because our robot is about 18-inch.
There you go.
So anything less than 18-inch, I think will be difficult for the robot to go in.
Also, obviously, if the manhole is below the level, the hydrocarbon level of the tank itself, and you can't open the manhole lah, because otherwise how are you going to insert the robot, right? If you open the manhole, definitely the hydrocarbon will spill out. Am I correct?
Normally the level I think is maintained. I think is around 80% or 70%.
But definitely you can't insert the robot below, for example, if the level is here
Mhm.
and the manhole opening is down here, obviously you can't open it, right?
Okay, okay, okay.
So
Yeah.
for the tank, the manhole nozzle is actually a little bit higher than the
Normal level,
normal level.
Ah,
So we have
normal liquid level,
around
sorry.
1 feet ullage, but this space is a vapor space and very
Quite
detrimental.
dangerous, yeah.
So we'll purge this area prior to deploy the robot inside the manhole location.
Okay, clear. Thank you.
Okay.
Zaidi,
Yeah.
Fauzi. I saw somewhere in your pack you mentioned about TRL7,
Okay.
and can you explain in what context you're talking about the readiness of that technology? Does it the robot or the methodology or whatever it is? Number one. Number two, you mentioned also that this robot eventually the industry is actually exploring kind of robot.
Mhm.
So mean to say those hardware with the wheel whatnot is a third party.
Mhm.
So I just want to know what exactly the context of that TRL7. TRL7 is commercialization. So
Mhm.
can you brief a bit on that?
All right. Okay. Let me explain. I mean, okay. Basically, we are not evaluating the company or the robot. We are evaluating the technology. So that's why, I mean, based on the slide, basically we have these all the 4 criteria that we are evaluating. So we are not so worried about, I mean, the changing of the technology later on. But I mean, all the technology has to meet all the criteria that we set up, I mean, for this robotic inspection. So that's why, like I mentioned, we are doing TRL based on the technology, but not on the company or specific robot. So it is really based on the criteria that we have set for robotic inspection.
So what you're saying here is
Hmm?
basically you are looking at applications
Yes.
rather than looking at the approach, methodology or formulations,
Yeah.
whatever, if you need so in the context of inspections.
Yep.
Right?
Mhm. It's rather on the application. Yeah.
All right, thank you, judges. All right, we have a question from the floor.
A good presentation. First of all, I appreciate.
Okay,
My
thank you.
name is Ravikant. I'm a custodian of upstream operations. I have 2 questions. One is related to hydrocarbon and a non-hydrocarbon. So is this technology is going to eliminate totally physical inspection? That means physically we need to inspect maybe based on risk based 5 years or 10 years. Because in the presentation you mentioned 10% coverage area only. So is it going to replace the physical inspection?
No, basically. So this is technology is used to just extend the internal inspection interval or the physical inspection. We still need to do the physical inspection where we can do the actual maintenance, such as the repainting of the tank bottom as well as repairing or replacing the tank bottom.
Then how is the cost saving? That means your extension is based on this robotic inspection, will be able to extend the life of the tank with the whatever 10% available data?
Yes, so typical tank OS interval is 15 years for hydrocarbon tank. So with this technology, we can extend to 25 years or 30 years. So it's just a matter of postponement the maintenance cost for another 10 years.
So, and Rasidan question. So you need to have a shutdown. Of course, no need to clean the tank, but as mentioned, if the manhole is a little bit on the higher side, you need to take a shutdown. It's not online, isn't it?
To do the robotic inspection,
Yes.
what you saying? No, we do the inspection online. So we have the safety interlock system to insert the robot and to perform the robotic inspection online.
That means if the level is above the manhole, how are you going to do?
So for cone roof tank, so usually the level is below the manhole level. For floating roof tank, we have a nozzle about maybe 30-inch higher than the actual product level. So we able to manipulate that vapor space to insert the robot.
Okay, thank you. Second one is regarding non-hydrocarbon. Non-hydrocarbon is very easy. We can remove, we can check physically. Is it really advantageous to do non-hydrocarbon like water tanks and all? We can open and we can inspect, isn't it?
A good question, sir. But these non-hydrocarbon, for example, fire water tanks or our damming water tanks, cannot be shut down even during turnaround because we're still using the water or fire water to some cases. So with theory, we can able to optimize the date to do the shutdown.
Okay, thanks. I will catch up later.
All right,
Okay, thank you.
thank you.
Thank you.
Thank you.
All right, we have two questions from Prakash, one of our judges. So his question number one is, how do you introduce the robot into the tank with the need to remove oxygen prior to entry? That's the first question. Second, have you achieved a level of certification that would give some level of comfort to operators?
We have a purging system to introduce the robot inside a hydrocarbon tank. In the meantime, all the electrical or the potential soft ignition is actually capsulated and also in a nitrogen system. So there is no oxygen during the inspection activity. And the robot will not be energized ataupun turn on prior to the insertion of the robot at the bottom of the tank. The second question, maybe Zanin, the certification required?
Okay. I will say the robot itself doesn't have the EX certification, but the component of the robot has. So basically, like TP Hisham, I mean, it is related to the deployment of the robot. I think the robot, I think the environment is basically we call it. I mean, we have this nitrogen to blanket the area to remove the oxygen present, and then I think we don't energize the robot when we deploy it. I mean, inside the tank. So the risk of, I mean, we already eliminate the oxygen, the triangle, the fire triangle, the oxygen, and the source of ignition until, I mean, we energize, I mean, the robot on the tank bottom.
Yeah. To add on that, assurance to the operator is also given through the risk assessment as well as the GHA development.
All right, thank you. Any more questions from the floor?
I don't have a question. I think I just have a feedback. It's over here. I'm the one of the
Okay.
judges.
Sorry. I didn't see.
Okay, so just now we saw the evaluation criteria, right?
Mhm.
This is just not for this team. I'm also talking